Hello and welcome back to the lab. I'd like to take a moment to thank everybody who's joined us in the lab recently. Welcome and thanks for being here. I'd also like to thank all the Patreons who are helping me out with the channel directly, and especially when I have some channel-based decisions to make. Your advice has been invaluable to helping me get the channel going and getting everything out there, so I greatly appreciate everyone for being here, and especially appreciate the Patreons who are helping me out and helping make these videos possible, so thank you again. In this particular video, we're going to take a look at the trigger section of this scope, the 465B. The adjustments in the trigger section are short. If I remember correctly, the first 6 steps are the adjustments. Everything else after that is validation. Just making sure the triggers fire when they're supposed to, not when they're not supposed to, and that's pretty much it. So what I'm going to do is I'm going to do the adjustments on camera. I won't draw the video out to just fill up time with just validation, because I'll just be checking the scope and it would be very boring because there's nothing. It either works or it doesn't. But what I'm also going to do is, after the trigger section's done, I'm going to go right into the horizontals. So where I thought this was going to be split into 4 sections, I'll do the triggers and the horizontal in the same one. There will be a lot of adjustments in the horizontal just from doing one of the 7000 plugins. One other thing I'd like to ask all of you guys, everybody who's here, for part 4, I have a second 465B that I need to restore and bring up to par. This particular 465B was an absolute nightmare when it came to troubleshooting the vertical section. If you guys are interested, I can go into a deep dive on how I service the attenuators to get this guy back up and running, and go from there. My other plan for that other 465 is to test. I used Deoxit Red in this one, the D100. I have Deoxit Gold G100, the 100% solution, that I plan on using in the second one. See if it does a little better, see if it cleans it up, but I don't know. The attenuator in this one was too badly corroded for just the alcohol and paper cleaning trick. It was pretty rough. The other one, given what the case looks like, I think it's going to be even rougher. So if you guys are interested in a real deep dive on how to service the attenuator section on one of these scopes, let me know in the comments, and when we get started on 465B number 2, I can do a video on that. To do the calibration the Tektronix way, they want you to have a CT3, which is this thing right here. So signal comes in, comes through the CT3, comes out, 10x attenuator, 50 ohm termination to trigger. Most of the signals are done off of a SG503. You then have 10% of the signal that comes through here, coming out here, going into here, and then going into these 2 channels. Going through the calibration procedure, I did not find any reason why the dual input couplers were necessary other than convenience. Hooking it up this way, you get the same signal on both sides because you have 10% coming off, you have a 10x attenuator, so it kills it by 10 times. And you actually can plug them into all the ports, so you don't need to move anything around. I expect you could do this calibration with a single cord. It'll just take longer because you won't be able to just switch between the sources. So if you need to do one of these, my opinion, the dual input coupler on this one is not necessary because is not required, because you're not comparing the triggers on the 2 channels. So you're not like comparing channel 1 and channel 2 or A and B, where you need where the delay of the cable is going to cause a problem. That is not true on some of the other adjustments, specifically common mode rejection, phase delay between the 2 inputs. Absolutely necessary. Just for the trigger section, it's overkill. But it's the way they told us to hook it up, so that's what we've done. SG503 to here, out to the 10X, to A and B trigger, and then The 10x goes out to channel 1 and channel 2. Let me get this set up to get started. 10, calibrated, positions are mid-range. Vert mode is channel 1, inverts off, 20 megahertz is off. Slopes are positive, everything is set norm. We are on A trigger. Fully counterclockwise. Yep, delay time is off. And we want 0.05, so we're going fast. 10x mag is off. Trigger hold off is norm. And the first thing we need to check is the trigger sensitivity. 10 megahertz of signal. And it wants 3 divisions of display. So when I adjust the divisions of display, I find that de-triggering can actually help. And then you can set by the envelope. All right, there's our 3 divisions. Set channel 1 volts per division switch to 0.1. So that gives us a 0.3 division display. We can get a stable display on plus and on minus. So we are good. Also, the triggered LED is coming on. So now we need a 2 divisions of display at 0.5. There we go. Now we go to 1. And that gives us a 0.2 division display. And if the trigger sensitivity is set right, it should not trigger anywhere. That is perfect. So, if the trigger sensitivity needed to be adjusted for a trigger, it would have been this potentiometer right here, R7246. But because the scope behaved exactly like we expected, we can skip to step 2. So we need to check B trigger sensitivity. So same thing. 10 millivolts, B trigger. Detune. B starts after delay will detune the sweep so you can adjust the envelope. And 3 divisions at 10. There's our 3 divisions. So now we kick this down to 0.1. Oh, normal mode. And let's see if we can't dial up. There it went. We can get a stable trigger, so that is good. Let's make sure 5 by 2. Actually, wait. Check -2. Yeah, it works. When you're adjusting the trigger, plus tends to be slightly less sensitive than minus. It has to do with the physics of the silicon and the tunnel diodes, but the minus side, falling edge triggering tends to be slightly more sensitive. Okay, 0.1. And I'm just turning the knob, making sure it won't trigger at all. And it doesn't on either slope. So B trigger is working normally as well. B trigger sensitivity is right here if you need to adjust it. So now we need to check B trigger's slope center and level. Starts after delay. 10 microseconds. We got to slow way down. 10 mic. B trigger level 0. And the 0 trigger level is important on these. Once you set 0, don't move it. Bumping it means starting over. $10 mil ground. Turn this down a bit. DC norm. 4 divisions of 50 kilohertz. There's about 4 divisions right there. Okay, so I'm going to bring this over so you guys can see it. The point of reference is going to be this point right here. So as I switch between positive and negative slope, that should stay the same in theory. And it is. It's switching at exactly the same point. So that's balanced. If that needed adjustment, the slope center R7042 would have needed adjustment. It doesn't. And R726 could use some slight adjustment. But if you adjust 726, it'll interact with 7042 and 7045. So you kind of do this dance. You just roll through it again and again and again and again and again until it doesn't improve anymore. 7026 is here. So we'll bring that up to the center. And there we go. Yeah, it just drifted off just a little bit. So that's about as good as I'm going to be able to get it. So we'll check the same thing with A. Check A trigger. Want that dead on 0. And we just flip it back and forth. Okay, that's the same thing. It's switching nicely, but it is up there. It started to drift. And it could use a touch of adjustment. A trigger level is here. A trigger slope center is here. So you're adjusting these 2 pots to dial in the trigger. So what I need to do is slope center. No, that's to make sure they're switching at the right point. Trigger level 7224, which is the one closest to the front of the scope. All right, I'm going to adjust trigger level or slope center just a touch. Yeah, now the slope center's off, but let's move trigger level up. Slope center down. Ooh, way off. I am not switching at the right point. There we go. That's close. Nudge that a bit more. That's going to be as good as it's going to get right there. Okay, and that concludes step 5 of the trigger adjustment. That is actually all of the adjustments left in the trigger. Everything else is validation, just checking to make sure the trigger fires when it's supposed to, doesn't fire when it's not supposed to, and going through. So that's all there is for the trigger section. Pretty quick. We're going to move into the horizontal adjustment because that one's going to be a while. I do need to wait for the 184 to warm up, so I'll get that warm up started, and then we'll continue on with the calibration. But for now, triggers are... I will go through the rest of the document, and if anything doesn't work, I'll bring you guys back and let you know. But everything else is just checks. Boring and tedious stuff. Okay. I am back at the bench. We have the appropriate gear warmed up. I'm ready to do the Timebase on this 465 and get it off the bench. Gear that's warmed up is the SG503, the TG501, and the PG506. I also have the frequency counter warmed up just in case I need it. I'm not using the 804 at the moment, or the 184 at the moment, so we're going to do this one with the TG501. 184 is typically for geometry. Initially when I turned it on, it looked like I wasn't going to need adjustment, but it is. We've got a good line here, but we're off. And since we're doing a calibration, we will get it as good as we can make it. Okay, so since we're adjusting it anyway, let's see what our 4570 actually does. Okay, well, first up, we got to find our 4570. So let me figure that out, and I'll be right back. Okay, B-sweep start is actually on the bottom of the scope. So we'll turn up the B intensity. Let me check this because the timing on this is going to be good. So I need to get directly online with the screen. I'll be right back once I get the positioning adjusted. Okay, I have the time markers set up. Delay time position is exactly 1, and we are on this rise. So what we want the intensified portion to start is right here at the beginning of the time mark. So this is too far. This is after the marking pulse. So I need to bring this back to, and it should be on the second mark, which it is. Okay, that's after. So I need to speed this up. Right there. It's on the mark. You can't see it because the rise is so fast, but it's on the time mark, so that's perfect for the adjustment right there. Okay, now what we need to do is we need to roll up the delay time position to exactly 9. And I'm going to move the positioning. Now we need to adjust 6053. 6053 is Sweep Cal, which is on the timing board, so I have to turn the scope again. I am being exceptionally careful as I am doing this with the scope on, not to touch anything and get blasted. Exactly 9. 6053 Sweep Cal is up top. Right here. There it is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10th marker. It does. Now we do it over a few times just to make sure everything is good. So I'll move the camera, tilt the scope back up, do it a couple of times, make sure there's no more improvement, and that'll conclude step 1. Okay, we're going to check the differential time linearity. So, 10th marker at the beginning of the sweep. Okay, that's right there. And we need to make a note of the delay time position, which in this case is going to be 9, we'll call it 9.5. Okay, so what I just did was, to make the measurement easier, I used the trace separation graticule to bring it right to this line. So my reference point's going to be right here when I do this check. So that should be 8.5, and it is within spec. Let's go backwards. Bring this down just a touch. Yep, 7's good. Extremely touchy control. 6 is good. 5 is good. 4 is good. 3's fine. 2's fine. And 1's fine. All right, cool. Next is adjusting R 4373 and 4271. 4381 is on the bottom again. Starting to get a little nervous doing that around the camera, so I'm going to move the camera in between each one of those. Okay, 4274 is here, not to be confused with the, this is the X gain, not to be confused with the 1X gain, which is down here, which is actually set in step 18 of the horizontal calibration procedure. So, this is the pot you want for the X gain. So let me get repositioned and we'll adjust that. Okay, here we go. Actually, I'm going to turn off Timebase, given the way that was adjusting, to make this more clear. Now, my reference point on this is going to be the top of the marker. Doesn't matter what you use for the reference point, just be consistent. That's too far. I couldn't ask for better on that one, so we'll go with that. Turn that up so the camera can see it. But that is really good. Okay, now we need 0.1s. 10x mag. The mag gain is the other pot that's right next to that, which is good. That makes it easy. Yeah, it's a little off. Not bad, though. All right, I need to be straight on this one. Okay, and here's our magnified sweep. Now that it's done. I did have to play with the position control a little bit. That's expected on this one. So, linearity looks good. Back to slow speeds. Linearity also looks good. All right, so now we need to check and adjust the magnifier centering, which is 4253. Okay, so we push the beam find button. That's centered. That's pretty centered. Okay, it wanted me to select 5 time marks and release the 10x, which we've done, and the middle time mark is within 0.2 divisions. And we want magnifier registration 4275. All right, 4275. Right to the center. There we go. And it's looking for no shift between mag in and mag out, and we are good. So now we need to do the B-sweep calibration. Well, I would say I was going to calibrate the B-sweep, but I just got everything set up, and the B-sweep looks just fine. 1 millisecond time markers on B-sweep. 6052 if it needed adjustment. 6052 is on the timing board up here. So A sweep cal, B sweep cal. So we need to check A sweep length now. So back to A sweep. 1 millisecond time marks, or 1 milliseconds, and 5 millisecond time markers. 5 millisecond time markers. 1, 2, 3. And what they want you to look for is that the sweep goes to 1 division, which it does, right here. Awesome. So A sweep length is fine. So now we're down to 2 milliseconds. 5 millisecond time marks. We may have a problem. Yep, we do. I have no control over the Yeah. I have zero control over the variable time for division. So a little bit more troubleshooting. Okay, after cleaning up the control a little bit and working some things, I think we're starting to have I have to check the schematic because I haven't even looked at the schematic yet, but I think we have a transistor problem because I can control the variable time per division, and then it just falls off. So I actually do have control, but I have nowhere near the sweep that I should have, because this is, like, I feel the switch detent. That even could be the resistance in the switch. So this pot may be bad, so I need to check a schematic and figure that out. So let me see what's going on. Hopefully I don't have to pull this board out, because that'll mean I have to recenter the triggers and all that other stuff, but we'll see what happens. Okay, well, here's our circuit in question. So Q6032 is fed by this switch opens, which allows the current to pass through the variable resistor, which is the resistor that you control with the front control of the scope. This switch opens, that feeds this capacitor up to that voltage rail and Q6032. So what I should have is, if I DC couple a scope, check the base of Q6032, I should have a controllable voltage with this resistor. Let's see what happens. Okay, I have DC coupled channel 1 on the 7603. And if I turn the variable control on, nope. Now what I can do is, as I engage that switch, I can give it some resistance, which starts, I can control it a little bit with the switch itself, not the pot. So the pot is probably dead. I'm going to check the transistor just to make sure. I don't think it's going to be a transistor problem. I am going to check that capacitor too, C6033, because if that's shorted and it backfed voltage, that could be what burned up the control. So let me check that cap for a short as well, and we'll go from there. But that means the boards are going to have to come out. Okay, and we have a very empty horizontal section. The trigger board's out, timing board's out. Here's all the connections. These are the bulk caps if you want to replace all of those. This would be a perfect time to do it. To get the boards out, they have these pin interconnects here and here to the bottom board. The timing board has a screw here and a bolt and a extension shaft here that holds it up. Once you get those on, it rocks out this way. You have to pop these connections, and it kind of just pulls out this way. This top board lifts off and out. You do not need to take the front controls out, but you do need to take the power switch off and the timing knob off. Timing knob comes off in two ways. You have to loosen these two Allen screws, and you have to loosen these two screws in the back. This whole thing comes off the timing shaft as an assembly. That's going to be fun to put back together. And that's what's left after you pull out the trigger board and the timing board. Here's the trigger board. There are the tunnel diodes. Since this is out and I have it open, I'm going to be cleaning all these switches. Getting these all, getting a decent shot of contact cleaner in there, cleaning them up. And here is the timing board with the cam switch. Somebody may have been in here already. I don't know. Oh, no. I took that off to get the cover off. That's right. So, timing board. If you are going to recap one of these units, do not replace this capacitor, this one, this one, this one, this one, or this one. Those are the timing caps for the sweep section. Replacing those only if they're bad. They rarely ever see high voltage, but these are selected at the factory to get them all to match so the unit will calibrate. Only change those if they're bad. Do not change those if they're not bad. Let me get this apart. Here's our problem. Hell, sometimes I do, and sometimes I don't get lucky. This is the carbon track out of the adjustable potentiometer. Both legs have come off the bottom of the resistor. I checked the carbon track. Carbon track's okay, but the interface between the carbon track and the outside world is completely dead. So, that's toast. Ooh. These timing fingers are in remarkable shape, given how old this is. So we're going to clean those up a little bit and get those ready for the long haul, since I got everything open. Replace that pot with a spare from the eBay test unit I've got, and we'll go from there. Okay, I've got the sweep board back in. So let me get the trigger board back in, get everything hooked back up, and we'll give it a test. Don't have the knob on the front yet, but everything is going well. Okay, I have us caught back up to where we were at before. So we're going to do 2 millisecond markers. And I can get at least 1 mark per division. So the variable is working. Perfect. All right, now we're going to check the horizontal positioning range. So there is, on this, you can feel it that much right there. That's a fine adjustment, and then there's a coarse adjustment. So it is a coarse fine in a mechanical arrangement. So I haven't run into that style of control yet, so that was a little weird. I'm glad I got a positive that is the way it's supposed to work and it's not broke. But if we crank it this way, sweep should end left of center. It does. Delay time position now needs to go to 1.0 exactly. And 10 mic and 1 mic. Ten microseconds for time marks. And we're adjusting the 10 microsecond timing, which is C6002. So it's this capacitor right here on the sweep board here. Or the timing board, not the trigger board. But that wants a low capacitance screwdriver to set it. So we'll need to use the ceramic. And let me get in there and get this adjusted. That is pre-adjustment, so there's nothing that needs to be adjusted there. Now I need to go to 9. Alright, so now we need to do 1 exactly. Be delayed. Now we go to 9 exactly. 9's a little bit off, so I need to adjust that capacitor a bit more. So let me get that adjusted, and then I will bring you guys back. Okay, I've got 9, and my reference point is this X right here, or the crosshairs right here. But if I roll it back to 1, on this one, the positioning is what's important. So as long as it's on the same point on the waveform, that's what matters. The absolute, what the wave shape is less critical. And there's 1 exactly. So that is the 10 microsecond timing. We need to adjust A sweep high speed timing now. 1.5. Sorry about kicking the camera. B trigger source starts after delay. .5. 0.5. Our A sweep timing looks really good. So 615 does not need to be adjusted. Check the horizontal, be delayed, normal trigger. And that's perfect too. So the if we did need to adjust that, it would have been C141. So we'll roll through the timing accuracy here real quick. A trigger. $20 nano. There we go. Just walk this down. Yeah, that looks good. And that looks good as well. This is 0.5 mic. I like it. Looks good. This may be the last cow the scope ever gets, because it might be the last one it needs. That's off a touch. How far are we off? Oh, we are slow by 0.6%, so that's within spec of the Timebase. This is actually looking very, very good. Too far. Okay, epilepsy warning. It's about to get flashing lights. Yeah, that's good. That's good. That one's okay. The trigger timing is off a little bit, so it's... Cool. That one works too. I'll check B-sweep here real quick, and everything should be good. Okay, it's a bit off on the highest speed timing. These are 5 nano. This is a 5 nanosecond waveform, so it's cruising pretty quick. These are my 2 adjustment points here and here. So C4246 and 4247. We'll be adjusting those. To do that, I'll need to rotate the scope again. And not get electrocuted while I do that. Of course, that would make the video interesting. These are right by the horizontal output of the tube. Uh-oh. This doesn't want to turn. Ah, there it goes. Okay, cool. My reference point was the top line here coming down, so that looks good. The display is centered, so that's good. 0.2. Display is centered, so that's good. So now I need to adjust C4246 for I don't think that's... that makes more sense. Okay, so it's 2 time marks per 5 divisions. So we have 1 time mark, 1, and then 2 to 5, 1, and then 2 to 5. So you want 1, 2, and 3 are where we're adjusting. I'm going to call that one right there. And now I need to switch this down to 0.5. And then we need to adjust the other capacitor for 1 time mark per division. And then we just go back and forth until it's the best we can make it. Pull this back in just a touch. I don't like it down here at the bottom. Just a little bit. Kick back. Some of these adjustments are kind of fiddly. All right, let me get straight on it, and I'll get it adjusted. I'm just fighting with it now, so... Of course, right when I give up and put the camera away and get in front of it, it only needs one more adjustment, and then it's done. I have to run through some timing accuracy checks. I'll do those here real quick, and then I'll bring you guys back. It's just checking some things. I'll come back at step 18, which is check and adjust the X gain, 4381. Okay, I'm set up to adjust the X gain. So I need exactly 4 divisions of display, which we have. So now what we want to do is flip this over to channel. Wow, that's way off. Okay. Okay, 4 channels of exactly 4 divisions of vertical. Turn this down so we don't kill the tube. Kick this down to ground. Bring this back down. Well, that's not too terrible. Now we just adjust X gain for exactly 4 divisions of display. I'd say that looks good. Okay, the last couple of steps in the procedure are just checks. So what I'll do is I will get everything hooked up, get everything all set up, and then I'll just come back and show the checks real quick. And we'll go from there, see if anything else is wrong. Okay, on this one the XY phasing is a little more open than I'd like by 0.1 divisions. So 10 divisions of horizontal at 50 kilohertz. Oh, wait a minute. I may have had the leveled sine wave generator set wrong. Oh, yeah. I had the frequency set too high on the leveled sine wave generator, so my phasing is fine. They want by 0.4. It is open less than 0.4. That's perfect. So measure the phasing at 50 kilohertz, not 280 kilohertz, and it won't cause problems. Okay, so kick this down again. Check BNZ, all the way through the ranges. B does end A correctly. So now we need to check trigger hold off, but I need to warm up another scope for that. So let me get a scope warming up. That's going to take about a half an hour to let it come up to temperature since we're calibrating some gear. Don't want to shortcut it. And then we'll check the A trigger hold off and make sure that works, and then that will complete the vertical section. So I'll be back in about 30 minutes. Okay, since I don't know where the microphone cut out, when I checked the X phasing and bandwidth, everything was good. The bandwidth was 8.3 megahertz. I needed 4, so that's plenty fine. This one was a little confusing to set up. You take a gate out of the back of the 465, put it into a 50 ohm terminator, into a different scope, and then you adjust the variable time per division for exactly one division of the bottom of the waveform. And then what you do is you take the trigger hold off, you roll it all the way to the other end, and you want to make sure the bottom of the extension got 10 times longer, which means it should be more than 10 divisions long. This one is. There's the start. And we go off the screen. It's right there, so we at least got 11. So that is in spec and it's working. Thanks for stopping by the lab today and taking a look at this 465B, the last of the 3 videos to get it calibrated and restored. At this point, we are finished with the calibration process, so this guy is set for the lab work, so he's going to go on the bench. I do have another 465B that if there's enough interest, I'll do a deep dive into the vertical section and tuning that up, getting it repaired, getting it ready to go. Have some plans for that one. I'm also going to do a recap of that one. This one's going to stay in my lab. The other 465B I have is destined for not my lab, so that one is going to get a little bit more in-depth service than this one did, because this one, if one of the caps goes, I can deal with it here. The one thing to note with these scopes is the tantalum caps that are in it. They've kind of gotten a bad reputation as being failure prone. They're not really failure prone. The problem is they're run right up to their voltage limit. So a 6-volt cap is on a 6-volt rail. When the main filters go in this, in one of these 400 series scopes, the ripple gets so bad it pushes the tantalums over their rated voltage limit, and that's what causes them to burn up. So always watch the voltage rails in one of these 400 series scopes. If you have questions, if you even think the caps aren't doing, the bulk filter caps aren't doing their job, change them. Just because of the way the units were built back then. If you guys liking what you're seeing, let me know. Let me know other videos you'd like to see. And I'm getting a lot of questions on the plugins that I use to calibrate these, so there's a video coming on that as well. So there's a lot of great stuff coming, and thanks for being here. I'll see you guys in the next video.